remembering now. So, okay. So again, we're going to be looking at this quantity, Lm squared equals Em times EH in each of these three things. We know what it is. They're equal in the parabola, but we're going to compare them in these two things. And how we do that is going to be, it's what defines these things literally, both as mathematical objects and as linguistic objects. So we'll talk about that. I mentioned again that this is geometry without ruler and compass. I mean, it uses ruler and compass, but it posits constructions of things like these conics, which aren't ruler and compass. And we'll go into how they were constructed in a little bit. So I want you to do to the ellipse what we did in the first part with the parabola. And so if you look on the back side, I have to haul it up. But if you look on the back side of handout number 9, which I'll have for you in a second. I'll have in a second. If you look on the back side of that, we're going to do something similar to what we did at the top of the first page. So you'll see that I have an ellipse and I have a bunch of stuff pictured, and I have X, Y, you can see various things that are pictured here. And the definition is actually more complicated, sort of similar to what we saw last time, but we're not going to go through that. We're going to cut to the chase and go to what he showed. So he showed this was the relationship among the objects in this picture. And again, he defined the ellipse by a certain, in a certain way, analogous to what we saw before. So what I want you to do here is I want you to go through and, using this as fact, translate that to letters, using contemporary algebra. And what I want you to show is this is going to be your end result. And the way that I would do it is I would actually, rather than trying to do it geometrically, I wouldn't know how to do it. I would switch everything to letters. Lm squared is still going to be X squared. This is still going to be P. That's still going to be Y. Sorry, I forgot I wasn't sharing. I can't wait to go back in the classrooms. I'm sure you can't either. Is it sharing the handout, the back side of it?
Yes.
Yeah, I'm really sorry about that. We're sharing similar burnouts, I'm sure. So anyway, this relationship here at the top is given as a fact. I've translated things to letters. What I want you to do is to, using this as fact, is to get down to this point right here. And I'm looking for my annotation tools. It's not showing up, of course. Okay, is get down to this. And as before, this is going to be X squared. You can look up here and you can see that. EH is going to be this quantity here, entire quantity, that's going to be P. And then EM is going to be our Y. So it's very similar. So what I want you to do is show that this is what results. You'll have some, and you'll see when you'll have to manipulate things around. And then after you're done with that, to get a formula for the ellipse, okay, based on what you have right here. And I'm going to put you in groups to do that because I think it's easier to work with you all. And then we'll go through the rest of it. But again, this is much simpler than the last thing we ended class with. It's maybe a little bit more complicated than the thing we began the last class with. So I'll let you go and do that. I'll set up the groups. But before I do that, any questions? Okay. I'll set up four groups again. Actually, I might just do 3 because that way I can come around more quickly. There's 14 people here. No, some will have 5. So we're going to do 4. Sorry, my math is off. Okay, so I'll see you in the rooms. I'm just making sure your sharing is on because I forgot to turn it off at the very beginning. Okay, turn it on.
Which numbers did you ask us to go over again?
Well, you're going to be doing the backside. So basically, you're going to go through
We'll
1 through 6. Yeah.
Okay.
Okay. But I was just trying. But if you do that, basically, you're just going to start with that equality at the top, and just give everything letters, and you're going to try to show number 5. You don't have to go step by step. That's kind of cutting to the chase. Okay. And then the number 6, if we get to it, that's to show that you actually do have that you do get an ellipse out of all that.
Cool.
Okay. And I'm going to make sure everybody else's sharing is on, and then just let me know if you have questions, but I'll be back with you soon. Okay. I'm just making sure your sharing is on. Wasn't, so there you go. Mm-hmm. You should be able to share the screens now.
Right.
Okay. So basically, just give everything letters and try to show that this is true. So just solve for LM squared, and you should be able to get that.
All right.
Okay. And you have the letters for this relationship right here. Okay. So I'm just making sure everybody's sharing is on, but I'll be back in a couple of minutes to check on things.
Okay.
See you in a bit. Unless if you have a question right away. Okay. Thanks, Molly.
Huh.
Hello.
Hello. I'm making sure that you have sharing. I didn't remember.
Yes, we do.
Yeah, you do now. I just gave it to you, but I forgot to turn it on before I set up the rooms.
Gotcha.
Okay. I'm going to go look at the first group. I have to give them sharing privileges, but other than that, I'll be back. But do you have any questions before I go?
Not yet.
Okay. It's pretty straightforward. It's not quite as easy as the parabola because it's more complicated, but it's nothing like what you did at the end of class. So it should go pretty quickly. Okay. It's supposed to be a pep talk. Okay. I'll see you in a bit. I'm going to make sure you have sharing. I didn't have that. Now you do. Okay. Okay. Do you have any questions?
I guess not yet.
It should be straightforward. Yeah. A little bit complex, a little bit more than the parabola, the beginning parabola, which was almost automatic, but it's nothing like the proof you had to do.
Yeah, it's just seems like just replacing the variables and then you manipulate it a bit.
Yeah, you're going to solve for LM squared. Okay. 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 I'll let you think about it, and then I'll see you again. I'll see you again in a bit. Okay. Okay. Bye. I think we got everybody. So I like it. People did things in a really different way than I thought. One of the things that I do, I mean, when I analyze history, I have it's just the way that I think. I like algebraize it, and then that convinces me that it's true, and then I can work with it much better. And so I know that not everybody works that way, nor does everybody have to work that way. But that's kind of why I'm asking you to do it this way. And sometimes it all pops out in a second. And other times it's like the end of class yesterday or Tuesday where it's very hard. And so I think I noticed that some people, once they got on track, they were fine. And that's probably me not giving a whole lot of direction. But again, I think that that's a valuable thing, is not to give too much direction, even though it can drive people crazy, including people that I know that aren't students of mine. But so anyway, so So it's understandable that it can take some time, but I'm going to ask Bryce to do it, but other people were thinking this way, and I really like what he did. He gave a geometric argument, and some other people, I think, were thinking this at the same time, other people in this group, and I think in another group, which I really like. And so I think it's closer to the spirit of things than what I was doing, and dare I say, easier. So Bryce, I think you can share. I think I got yeah, you can share. Are you ready to do that?
Yep, I'm ready. Okay, so we start with our usual, oh, we gotta. DE over EH is equal to.
I'm not seeing, I don't know, it could be me, but I'm not seeing anything.
I'm not seeing anything either.
Oh, it's not letting me want.
I've had this issue with some programs too. It doesn't show. Oh, there you go. Now it is. Perfect.
Yeah, well, because
It just lags, I think, for us.
Yeah, that makes sense.
No, I know the reason why it did it. I have to try and figure out if it'll let me do it a different way now. Give me just a second.
Yeah. It might be quicker to just use the stupid drawing tool that they give us.
No, I got it fixed.
Okay, good.
Or I think I did. Okay, nope, that doesn't want to work. I'll just write it with my mouse then.
Okay, or I could well, oh yeah, go ahead, yeah.
So we have the thing that we start with, and then we just start like moving stuff around because we want LM by itself. So we get it over there, multiplying both sides by LM. And then we multiply both sides by the reciprocal of DH over EH. So we can get it on the other side. And we end up with EM times EH times DM over DE. And we separate these off by themselves because they have a very particular relationship in that DM is always a subsegment of DE, and therefore DM is always going to be less than DE, and thus the ratio is going to be less than 1, which means that it shrinks the entire right side down a bit, guaranteed. And so if you take it out, you can say that then EM times EH is going to be greater than it initially was, and therefore LM squared is always going to be less than EM times EH.
I like that. Okay, so I'm gonna coordinatize. Yeah, does that make sense to everybody? And I think this is probably closer in spirit to what was done. It's been a long time since I've gone through Apollonius in that way. Like I say, I cheat and use algebra because that helps me understand it better. But the way you might think about this is he might have said something like, you know, the square on LM is equal on the square, the rectangle EMH, and then he would apply a quantity that's less than 1. And it's very clear that EM has to be less than, is it DM or EM? DM, right? Yeah, DM. That DM has to be less than DE because DM is a part of DE and the part is less than the whole. You know, so I kind of saw that with Euclid to some degree. So I think it's a really cool way to do it. Okay, so what I'm going to do is I think I'm going to do the ellipse part, and we'll see where we go for how much time we have left after that. So what Bryce ended up with, and again, some other people were working on this, was this. And then let's see, times we had DM, yeah, DM, MD or DM over DE. So if we coordinatize, we get x squared equals EMEH, which is going to be P, or py. I'll switch those.
Your camera isn't centered.
Thank you for letting me know. I didn't have it pinned, so I didn't know. Okay, thank you. I appreciate you said something. Okay, so this is what Bryce had right here, and then forget about that. And then I'm coordinatizing it, putting the variables on it. I'm switching EM and EH, so it's PY, not YP. And then DM is going to be 2A minus Y over 2A. Okay, so, and I basically got the same thing from a different way. So what I did is, or what I had in mind for people to do was, I took DE, which is the 2A, and over EH, which is going to be P. Now we know that that's equal to EM, which is Y, times DM, which is 2A minus Y, divided by DE, 2A. Sorry, did I get that right? Yeah. Okay, and then if you just, sorry, divided by x squared. And then if you just do the cross multiplying, you get x squared equals py 2a minus y over quantity 2a. And that's exactly what was achieved there. And if I multiply this out again, the way that I think about it is my own way. I get py times 2a over TA, and then py squared over TA, 2a, and those cancel. So that's the way that I envisioned it, but I really like envisioning it this way. It's simpler and cleaner, or doing it the geometric way. It's simpler and cleaner. I think it's closer to the spirit of what what we're doing. Okay. So questions on any of that? Okay. And I could have been clearer in my instructions, and I apologize for that. Not all of that was productive lack of direction. Okay. So the other part, I just know people today don't have as much experience with conic sections, and that's neither good or bad. It's just the way that it is. So after looking from here, that's what I got. And then since I've done this a lot, I want to get that standard form for the ellipse. So I say, well, I have to get x squared and y squared on the same side. And so I'm going to multiply everything by 2a to clear fractions. And then I'm going to get all the square terms on all the terms on one side. Okay. So what I'm going to do is complete the square here. That's going to make me add some positive quantity here and here. And then I'll divide everything by whatever I get over here. So I'll go do that now. 2a squared, but first I'm going to factor out the p here, because I have a p in both of these terms. And I'm going to leave a space here for whatever I add, and that's all going to be equal to 0. Okay, so now I have to complete the square. Remember, to complete the square, you take the coefficient and cut it in half and square it. So I take 2a, cut it in half, I get a, and square it, and I add that here and over here. But really, what am I adding over here? When I add the a squared here, what am I really adding?
PA squared?
Yep, so I have to add that over here too. Okay, so this completing the square again, like it's, I grew up doing that, and I had to do it a surprising amount of time in my own research, which involves modern mathematics. Okay, so now I need to turn this into a 1. Anytime I have an x squared here plus a y squared term here, as long as these two things aren't equal, I know I have a true ellipse. If these two things are equal, I get a circle. Okay, so then I divide everything by PA squared. And I get y squared minus 2ay, sorry, plus a squared equaling 1. Okay, now remember the standard form for the ellipse is to put things, have the x squared here. It's just the way they do it. So if I can first cancel out this a with this a, and then to put this under here, I just have to flip the fraction. And then I do, here I cancel the p, and I already have the a squared below. And now this one is a nice square here, y minus a. And then over here I have 1. So that's what I was thinking for the ellipse part. And even here, once I got things to here, I knew I had an ellipse, because again, I had the x squared, positive x squares on both sides. The coefficients of x squared is different than y squared. And I just said, oh yeah, this is one of those, you got to complete the square to get it into the square form. Okay, so that's kind of what I had in mind there. Okay. So if I don't do one thing now, I'm going to do one thing now, and then I'll do the other thing on Tuesday, so I don't get over exuberant and try to cram too much in. Download number 10, that handout. It's in the handout folder, and look at I think it's the first one on there, and try to figure out what it is, and I'll give you a big hint once you have time to get it open. And I can even share my version of it. Okay, so if you look at the second curve on there, and I'll share so you can see exactly what I'm talking about. So I'm talking about, I don't know why it doesn't, that's stupid. And the annotation thing isn't opening up. Here, let me try it over here in the Zoom window. It doesn't matter. Okay. Sorry, I lost my own screen, so let me find it again. Okay, so look at that second curve and try to figure out what it is.
The second one?
Yeah, I said the first, but I meant the second. We're going to talk about the second one next week. And I'll give you a big hint. We've been talking about this thing all week. And what I did is I just took my pen or something long and just did what they told me to do with that straight line. So I did something like this. And then I moved the bottom around a circle and tried to imagine what I got. Here. So that's this is kind of my straight line. And then I hold it here and I just move the bottom in a circle. And I try to imagine what I get. And it's any straight line. Now, if you're good at multiple choice tests, is it A, a circle, B, a line, C, a parabola, or D, a cone that he's describing there? It's a cone. Yeah, it's a cone. He's describing a cone, and it takes a while to get there, and you really have to make a leap of imagination and maybe spend some time, on your own where someone's not, at the end of class telling you to do something. But he's describing a cone, and notice that straight line that isn't like, if you take a straight line and rotate it, I think again this is too big. If you just take a straight line and rotate it, like a perpendicular, you kind of see that you're taking out a cone. You know, you can put your pen on a piece of paper and rotate it in a circle. Imagine what the pen is doing, and you're getting a cone. Okay. That's how he created it, but his is curved. His isn't straight up and down. So it could look like, I'm gonna share something different. I gotta go find it first. It could look like this. Okay. Let me share this. Are you seeing a bunch of cones?
Yes.
Yeah. And you see the ones that are oblique, that aren't straight up and down? If you imagine what he's describing is, instead of the line that you see, oh, you're seeing it in the first one. Actually, I didn't get my cursor. Are you seeing my, no, that's just moving it. If you look over here, you see this line that comes like this?
Mm-hmm. That's the pen.
That's the one. If you just rotate that all the way around, you're going to get a cone. And he's rotating it through this place here. But again, he's extending the line in this direction, so the cone gets created here. So it is a double cone. These aren't double cones. So the cone that he's describing is an oblique cone. It does not have to be straight. So everything that he says is true, regardless of whether it's a regular cone, like a right circular cone, like this one, or whether it's an oblique cone.
You could make it a right circular cone by making the plane on which the circle is drawn perpendicular to the line to the right angle line.
Yeah, the generator. Let's call that the generator. Yeah.
The generator. Yeah.
Yeah, and you know, and you talk about when you do geometry. Again, I don't do a lot of really advanced geometry, but you talk about things that generate other things and things like that. So I think that's really cool. I think it's cool for its own sake, but I think it's also really interesting because it's showing he's getting. This is why this is not ruler and compass geometry. That's not a ruler and compass. It's what they often call a mechanical curve. He's creating some device, even if it's an abstract mental device in his head. He's creating a device to create that. You can create a compass, you can create a straight edge. Those are devices. And you can draw circles like, oops, you know, that's what ruler and compass. You could make a machine that did what he described. And I'm sure people made those back then because there was all kinds of funky stuff like that. And so we're going to see that other curve we're going to talk about at the beginning of class next week, and that's Archimedes' creation. Those kinds of curves were created to solve problems. It's also to explore. You remember who had I can't remember who in here had the doubling, the cube doubling? And remember, what objects did you need to double the cube?
It was the intersection of a parabola and something else. I don't recall. I didn't present that.
I think it was the second parabola. So again, these give you those things that you need to solve the cube, and you could use this to solve that doubling of the cube problem. And some people think that's really important. The curve that we're going to look at on Tuesday, which is the first one, I'll let you think about that, and we'll just start with that. That can be used to trisect angles and to double the cube. Remember, those things aren't solvable by ruler and compass, and there was some energy that was displayed to try to figure out other kinds of constructions that weren't ruler and compass, so-called mechanical curves that could solve those problems. And there's a big cottage industry of like proof of concepts where you create some other device to solve those problems. Anyway, that's what I got for today. So we'll start the homework. Let me know if you have questions about it. I can probably, certainly on Monday, I can find time to talk, and maybe over the weekend, and tomorrow's going to be a bad day. But just let me know if you have questions. I just discovered right before class that the Archimedes movie I wanted you to see, apparently the BBC got really possessive about it and pulled it from YouTube. And so the next project I had is, which worked great 2 years ago. I don't know. Right now it's on hold. So I'll punt and figure something else out over the weekend. So you're not going to have this video to this cool Archimedes movie, which is a shame. But I'm going to see if I can find it legally in a different way. I found it illegally, but I don't feel right about doing that. So at least to share it, I should say. That's a real serious breach of ethics. So anyway, so that's it. Have a good weekend, and let me know if you have questions on the homework.
Have a good weekend.
Okay, you
Have
too.
a good weekend, Professor.
You too.
See ya.
Yeah, I enjoyed class today, by the way. It was really interesting, so thanks. Okay.
Have a good weekend, Dr. Alexander.
Yep, you too.
Class.
Thanks, Daniel.
All right. I was going to
Oh.
ask if I can do it illegally, but
I don't care what you do on your own. I just can't ask you to do it illegally.
All right. All right.
Okay.
That's true.
I found it. And it was like, dang, I can't use the site. Hey, are you going to do a math capstone? You are, right, in the spring?
I have to, yeah, but I'm thinking I'm still very bad at it, so I have to plan like a lot of stuff lately.
Are you going to do you know if you're going to do the Pendleton class or the 1 hour with me? Have you figured that out yet?
Not yet, but I'll do it, find it soon.
No, it's okay. I mean, you don't have to decide until the spring.
Yeah, because this week is definitely a lot of stuff going on, and
Right.
I was really happy that someone asked for extension for the homework as well.
Oh, yeah. And you could use the Pendleton course for an upper level math course if you want to take that course and do the capstone with me. I mean, there's different things you can do to sort of get, you know, I know we talked about that, but I know right now you got too many things on your mind, but let's talk about it toward the end of the semester.
Yeah, definitely. But and the J-term, I'm definitely taking the infection one, the fifth Pendleton. So
Oh, good.
maybe great after that.
Yeah.
But yeah, I'll just continue doing all my stuff.
Yeah,
And,
we'll get you.
I think my camera is off.
Yeah, that's all right.
All right. I'll see you then. Have a
we'll
good
get
weekend,
you.
sir.
Yeah, bye-bye, Kika.